this talk is about, yes, kind of my experience, using AI to integrate in data tools in various ways over the past 2 years. And there is, an interesting analogy. One thing I'll talk about during this talk is how there is some interesting things happening in software. So some parallel between self-driving cars, in the history, and how it got developed and it's getting deployed, and what's happening in the software that we're using every day. So let's get started. So there's already been a good intro on me. What I would say just about myself is, like, I love to build data tools. Over the past 20 years in my career, one thing that I've been doing consistently, I'm not consistent at everything, but one thing I've been doing consistently is just building data tools. And that started pretty early on with like small scripts and grew into like larger open source project. The quick tidbit about Apache Superset: it's been my mission to get really my life's mission to get open source to win in business intelligence. So if you haven't heard or tried Apache Superset, I highly encourage you to check it out. Also, if you haven't tried it like in a year or two, it gets better very, very quickly too. So I encourage people to go and drop their BI vendors and try Apache Superset. At least I just give it a test drive. And the best way to do that is definitely on Preset. So we have a free account. So if you just want to check out Superset and see how good it has gotten recently or how much it has evolved, you can try it on preset.io, whether you're going to run the open source or whether you want to manage service. So that was the very short commercial portion of this talk brought to you by Preset. And let's get started. So I was thinking about, like, hey, what makes me a little bit qualified to talk about this topic, and why there's relevance? What's my vantage point to talk about how AI is getting integrated in data and data tools and the way that data practitioners are working every day? So a few points there. So one is, I've been a super avid user of AI since the super early days of 3.5. So I remember that, I believe that was December, like 2.5 years ago, 3 years ago, that GPT first came out. And ever since, I've been using AI all day, every day. I think a lot of us have, not everyone does. So I think, like, for those who have seen like every step of the way how AI is getting better, we have a pretty good vantage point as to how things are evolving. I've been a data practitioner, like very much full stack data practitioner, from data infrastructure, data engineering, data analysis, data visualization too. So, I've been using all sorts of data tools through multiple generations of tool. I've been building data tools for a while. We built a lot of RAG features. I would assume for the purpose of this talk that people are familiar with RAG at a super high level. If you're not familiar with the word, it's for retrieval augmented generation, is the idea of how you can build features in an app by retrieving context and using an LLM as a service. So we've built some RAG features at Preset. We've used all sorts of RAG type features and all sorts of data tools. We're also early adopters of MCP. If you don't know what MCP is, you're probably in for a nice, interesting discovery and learning something that's really important in this phase of rolling out AI. So I'm going to have a slide or two specifically on MCP. So stay tuned to hear all about it and why it's interesting and disruptive. So we're early adopters and test drivers, I guess, for MCP and its promises at Presets. I can talk about that from the perspective of a builder. And then we've learned a lot through text-to-SQL as we were building that on at Preset. So some of the reason why I want to talk about this, and I've got an interesting perspective on it. One thing I wanted to talk about, I think it's important to distinguish for some of the AI use cases and how it works. I like to just categorize it in two big categories. One, there is where accuracy is critical, and there are use cases or workflow where creative input is welcome. And one way to think about it is like where you need, 100% critical, accurate result, like text to SQL is very much this way, right? Like really often, if you want a business user to ask any question and trust the number that they're getting, make business decisions based on these numbers, it's really critical that you have, high accuracy. Otherwise, you're gonna have some real issues with trust. And where creative input is welcome. Maybe an example of that is, you can imagine in Apache Superset, you write a query, and you'd like to see, can you suggest some chart to visualize this query? This is the kind of use case where, 70, 80%, 90% accuracy, right? It's on a spectrum, whether it's like 0 stars or 5 stars. These use cases tend um, to work better in some cases, right? And if you think about the analogy of the self-driving car, like that's very much an area where 100% is required, right? So this is the areas uh, where accuracy is critical. Pushing a little bit more, and I have not talked about it so far, but this talk is backed by a blog post that I wrote a few months back. So if you're interested to go deeper on the topic or to follow the flow or maybe reshare some of the ideas, there is a companion blog post. It's easy to find. It's on the Preset blogs at preset.io/blog. You'll find this post. But I wanted to talk about some of the parallels between the self-driving car and its evolution and how we've been on a 10-year journey, or it's accelerating in intricate ways, but we've been on a journey for the self-driving car. Now there are Waymos, going driverless fully in San Francisco, but that's fairly recent. So there are a certain number of markets where we're seeing this technology deployed, but it's been quite a moment, right? It's been a journey to get here. And some of the parallels I wanted to talk about is the idea that for critical use cases, you need super high accuracy. Trust is an issue. For these areas, what we've seen in the self-driving car area is an S-curve, right? And the idea of an S-curve, I should have had it on the slide, but the S-curve idea is like you get exponential progress and you get really quickly to maybe in 20% of the time you get to 50% of the progress or 80% of the progress. But then as you get closer to perfection or accuracy, or a self-driving car that is like fully trustworthy, that can really drive on its own, you get diminishing returns, right? And I think that's the phase that we're in. And some, pushing the analogy a little bit, I think that's what we're going to see over the next few years in software, is that while we are at the right level of accuracy for these critical use cases that are really some of the most important use cases, you're gonna see kind of a slowdown as we go. Another thing you're gonna see here too is while the self-driving car is still in development, it's still not perfect, you still need a steering wheel, you still need pedals, and you still need a driver with a driver license that's sitting in the driver's seat to oversee what the car is doing, right? So that if there is an obstacle on the road, if the computer has some sort of issue, there's something unusual, it will pass the wheel back to the driver. And the point being here is, unless, we all know that the self-driving car is going to go to a place where you have a car without a steering wheel, without pedals, where the seats are probably facing each other, front seat, back seat are facing each other. But I think it's going to be quite a while before this happens. If you translate that to the world of software, that means I think the AI revolution is going to happen in an environment that we are familiar with, right? So that means that you'll still need, in the case of BI, you still need a place where you can drag and drop, explore data, create a dashboard, write SQL, something very much like Superset. But you'll be able to give the wheel to put in self-driving mode, and you'll be able to get in, you're able to get in self-driving mode, but also to fall back and come back to being in the driver's seat, right? So you decide, oh, I'm on the freeway, this is safe, I'll use the self-driving features and the workflows that work by themselves. And now I'm getting in an area, maybe I'm working with some data sets that are not as well organized or documented, or don't have good semantics, so I'll take control of the wheel. So an interesting analogy there. Some realization, I'll talk more about that, but you need a driver in the seat, right? So like, I don't think very much, a lot of people would send, their kids in a Tesla today without a driver, with a driver's license, in full self-driving mode, right? So that means the parallel here is, would you let a business user that doesn't know SQL, doesn't know the data, self-serve and answering any questions? Well, maybe in a safe environment, maybe in a specific city where like Waymo is not allowed to go to do trips to the airport. So similar to that, maybe there's some guardrails in some areas where you can let business users self-serve. I think we're very much in a phase where you need someone that knows what they're doing at the wheel, just in case something happens. Some of the things that are required for full self-driving analytics, right? So we work with this. We've seen AI, depending on the context, depending on the database it's working with, depending on which context we might retrieve through RAG. What does it take for an AI to self-serve and get to 95%, 95, 99% accuracy? So we need first for the AI to have the basic metadata, right? So the basic metadata is table names, table description, column names, column description, data type. That's the basic. Now, having extended metadata, what can be joined together. So here we're starting to touch on the semantics around the semantic layer, but the more metadata you have about where's this data coming from, how is it used, right? If you have examples of certified queries that have gotten good results to people, the AI can infer a lot from the usage pattern, also from like popularity type patterns, right? So if some tables have some statistics that they're used often by a lot of people, that's a good sign for the AI as to like the usefulness or the reliability criteria behind a given data set. And then there's all the soft knowledge, right? So that's, we used to call it tribal knowledge internally at Airbnb. That's a term that's been used everywhere, but that's what's on Slack. That's what happens in places like, Notion or your wiki, in documents. That's, some piece of information that in many cases exists only in, data analysts' brains and things like that. So there needs to be a way for the AI to tap into this knowledge. So that means like we need a human in the loop interface to oversee some things, right? Until we get to 90, not 5%, 99% accuracy, we need a human in the loop in many cases that knows what they're doing to say, yes, this SQL is valid, or yes, this is the right set of tables to answer this business question. Feedback loops can be pretty useful too, right? So that means there needs to be a way for someone who knows what they're doing. Maybe that's a labeler, someone who can say, this is good, this is bad, so that the AI can learn and hopefully get better over time. And then one thing that we've seen, I think a lot of us have tried to prompt model to say, if you don't know, just let me know. It's cool if you can't answer this business question, or if you're only like 20% confident and 50% accurate, do not answer. Ask me for clarification or say, I just don't know. AIs have been extremely eager to please, and that's been deceptive in many cases. I think we're doing better on hallucination overall, but just the self-awareness is not very good. There's been some research in trying to get the AI to not only answer the question, but to say, what is my confidence around answering this question? And we've observed that it's not very good at doing an assessment over its own its own accuracy, right? So there's some progress that needs to happen in this area. I wanted to talk a little bit about some of the learnings of building text-to-SQL. There are blog posts, so they're on the preset blog. I think there is more of an architecture blog post of like how we built it architecturally, and there is some more information. So I believe there's a pair of blog posts if you're interested on the feature. I believe you can try it too in the trial. So if you're interested to play with it too, you can certainly try it in preset. Just to describe the feature, it's a text box at the top of SQL Lab, which is a SQL IDE that ships as part of Superset. And you can ask any business question on a given schema, and it writes SQL for you. So a few things we learned, I think, early on, and that was, we shipped this feature about 2 years ago or a year and a half ago. And we thought that custom training and fine tuning might be really interesting, though we realized that it was super prohibitive based on costs. And there's some issue around segmentation or leakage, right? So if you want to train a model on your own on real data, you're serving a bunch of customers, you definitely don't want to train an AI across your customers and then serve a customer. So you have to train a model for each one of your customers, and that stuff is super leaky, dangerous, expensive, and as far as I know, the world is just not ready for us to do this, and there's much better approaches now. So one is RAG. So it's the general idea of retrieving context, putting in a prompt window, asking the AI, asking for structured results, and then using the answer. That's good. Another thing we've learned is that privacy and roles-based access control are a real concern for adoption. So it can be when you do RAG, or if you train a model in a certain way, it's really important to be able to segment information, make sure that one customer is not going to see information from another customer, or one user with elevated rights should not see things that or with de-elevated rights should not see what an elevated user sees. So there's some challenges even in interacting with a vector database where you need to make sure that not all users have access to all the vectors. There are some magic moments, and there's quite a few of them, right? Especially like the more intelligible your data schema is, the better the AI is going to do. Right? Like that's pretty self-evident in many ways. But if you have a nice little star schema or set of star schema, they're well documented. You have good nomenclature. You've got nice description. You have statistic metadata at your fingertip. The AI is going to do extremely well. The reality, and one thing we learn, is that real data warehouses are super messy, right? So I don't know what's the state of your data warehouse, but you imagine maybe another analogy. You think of like an Amazon warehouse where everything's super well organized and structured, and just like label throughout the warehouse. The reality is the warehouse looks more like it looks more like a dump in a lot of cases. Like the typical data warehouse looks more like a dump than a pristine, Amazon type warehouse. So that is a tough reality, especially if you're working blind, right? Of course, the AI has access to the customer's warehouse in our case, but we don't, right? So we don't know when someone's gonna start using this text-to-SQL feature. We don't know the level of messiness of their warehouse, right? So we can't predict the results. And then, another really important learning, and I alluded to that, and I'll bring back the analogy with the self-driving car, is that if your car needs a driver with a driver's license sitting in it, then you're not winning all that much, right? I cannot put my kids in the car. I have to go in the car and drive them. And if I'm sitting at the driver's seat, might as well drive, right? My time is committed. My attention is mostly committed. And that means that you will fail at the self-service, the true self-service type idea. All right, so I want to talk about MCP, and that might be my closing topic. I believe I've got 2 more topics. I want to try to wrap up. I've got about 8 minutes. So MCP is an emerging technology, is the Model Context Protocol that has been announced by Anthropic, or proposed to Anthropic, and I believe the whole AI community has been rallying over the past few months around this idea. If you're not familiar with the concept, I'll try to explain it as best I can. And if nothing clicks while I talk about it, if it's the first time you hear about it and nothing clicks, like, you need to do more research until you get it and why it's important. So in the context of RAG, right, the general idea is your app uses the LLM as a service, right? So the app has context from its metadata, its data, your recent action, and it's going to package a little something and use this mushy interface that is an LLM to ask a question, hopefully get some semi-structured data, and assist the user in their workflow. So pretty simple. Your app is the service and your app is the focal point, and the LLM is a service that your app calls. With MCP, the Model Context Protocol is a protocol so that LLMs, right? So chatbots like ChatGPT and Claude can access your app or the app the user is using on its behalf. So here you can kind of see the model where the LLM is the focal point, and then it has access to multiple tools. And this has some really interesting properties, and flipping the paradigm here can be really interesting. I'll try to give an example of this. So say you're working with data, you're using Airflow Superset, of course. That's a personal bias here. Let's say you're using GitHub, maybe dbt Cloud, and Slack, right? So that's when you think of what a data practitioner does every day, they have some context and they build with a variety of tool. Often the information lives across a variety of tool, and you need to retrieve information and take action in these different tools. So with the MCP model, and I wish I'd made a diagram for this, but like you can, let's imagine a session where you're inside Claude or ChatGPT and you say, can you help me, create a dashboard about our recurring revenues? And what the AI can do there, it can start interacting with Superset to see if there's anything, if there's any dashboards that exist that have this type of information. It can initiate a conversation, or it can use some tools, right? It can go see on dbt Cloud if there's some data sets that might be useful. It might be able to interact with your data catalog to gather information, and then it can take action, right? It can say, I'm going to create a set of chart. I'm going to ask you for feedback. I'm going to create a dashboard, give you a link to it. It might say, hey, I wrote a little bit of SQL on some data sets that I found. I'm going to take you to SQL Lab inside Superset for you to evaluate and use these things. So it's really flipping the paradigm of what's happening. I think what we've seen over the past 2 or 3 months since MCP has been announced is everyone is shipping an MCP service, to a companion service for their SaaS application or their tool. So highly encourage people to start messing with this stuff, as it's super promising. It's also very early. So what is MCP really? You can think of it like a REST API, right? A REST API as endpoints and information retrieval capability and taking action, like creating objects and CRUD type interactions. And MCP is essentially just a REST API intended for LLMs. And the thing that's different than the REST API is, instead of having an API key, you're going to have like an OAuth type handshake. So that means that when a user in Claude says, I'm going to register this preset MCP service, then there's going to be an OAuth handshake, and the user can decide what kind of rights it's going to give the user. Another thing that's really interesting is the fact that if the user has admin access, then or the user will only be able to grant access to the tool to a subset of the rights that they have in the tool. Last big idea before wrapping up is the idea of the semantic layer. So recently, Snowflake, at the Snowflake Summit, they announced a new semantic layer for Snowflake. They call it semantic views. For those that are not familiar with the semantic layers, the general idea, a good analogy here is it's the menu to your database, right? So maybe your database is like a restaurant. There's a lot of complex, ingredients and dishes that the restaurant can make, but the semantic layer is the menu. So it's a subset of the things that the restaurant can serve. These semantic layers have existed for a long time, so there's nothing new there. But what people realize recently is that if you give access to an AI to the semantic layer, it's much harder for the AI to mess things up, right? Because The menu is the map. Like you can't really order something that's going to be disgusting because it's on the menu. So generally, I think the semantic layer is promising as a mean um, to provide more metadata for LLMs to understand your data and get things right. One thing that one of the shortcomings of the semantic layer is that not everything has semantics, right? Or in your data warehouse, if you decide to do a push to build a semantic layer, then I would highly encourage people to look at something called Malloy. That's an interesting one. Cube.js, that's been around for a while. Super cool semantic layer. DBT, a ship one. I believe the people behind SQL Mesh and SQL Cloud are also building one. So lots of innovation, kind of renewed interest for the semantic layer, and promises around the semantic layer helps intelligence, whether it's a human or an artificial intelligence, to kind of make sense of your data in a better way. So check out the semantic layer as something useful and maybe a mean to enable AIs to be more accurate. Also, just saying that there's a behind the tip of the iceberg of what has a clean semantic layer is very well structured. There's still all that unstructured, that data that's messy in the rest of your warehouse. I don't think it's a solution for everything, but in this day and age, it's a great factor for people to get a kickstart maybe on getting better results while using AI. So check out Cube.js, check out Malloy, check out the DBT semantic layer if you haven't looked at these things already. Now I'm wrapping up, and I know I'm at time, so a little bit going over, but some of the key takeaways from me is first, don't schedule yourself for talks at 7 a.m. I'm still a little fog brain, but I'm waking up as I speak to you guys. But one thing to remember is I believe the revolution will happen on familiar ground. So it's most likely it's going to happen in the tools that you use today. And you'll see things like MCP and things like RAG features come in on grounds that you're familiar with, so that you can see what the AI is doing. And we're not ready for the black box, right? The self-driving car without a steering wheel, not for a little bit of time at least. So that's an interesting takeaway here. Trust is difficult, right? Trust is really difficult to get. It's really easy to lose. So that's going to contribute to this S curve where we're going to see a slowdown as we get to closer to a full accuracy. And then last point is, I spoke about MCP. I'm not sure if I'm the best person to explain it, but if it hasn't clicked with you, do some research, look at it, go play with some MCP services, try to mesh multiple MCP services to work to get an AI to interact with multiple tools at once. And I think you'll get that kind of click moment of like, oh, this is going to be the model for how we work with AI over the next few years. So that's what I got. Thank you everyone for listening.